Último ejercicio, a ver, cada del último ejercicio.
La última K de cada ejercicio, del 2 y el 3, es lo que suele fallarnos.
El
De
2 y
hecho,
el 3.
el 2 y el 3 del
Este es
ejercicio
el
2.
2. Este no, este es el 3. Este es el 2, el
Este es
K.
el primero, ¿no?
O este es el segundo, Manning's equation.
No, yo me
Me
refiero al de
imagino
la
que se
segunda
refiere a la
tubería.
segunda
Segunda y
línea.
tercera tubería, ajá.
Ah, no te sale. Ah, ok, no, pero pues es que esto es ejercicio, yo no te puedo ayudar en tu ejercicio.
No,
Ahí
más
tienes
que
que
nada
confiar
No,
en
es
el
que
resultado.
el
para
problema
saber
es que el último valor de
de K de la
K
segunda línea y de la tercera no nos da.
no da.
Ah, pues
Los
ahí sí
valores de
tienes.
todos los demás valores sí dan, es menos ese.
Bueno, puede que esté mal el libro, ¿no? Puede que esté mal el libro. Yo así no le puedo ayudar, pero tengan confianza y fe en lo que usted les da.
Ok.
Okay, yo ya tengo acá abajo, miren, acá está el lado de ejercicio, pues no se los voy a mostrar. Porque si
Ah,
no, pues es que chiste, ¿no?
está bien.
Pero bueno, si no les da, puede ser que el libro está equivocado. Tiene ciertos errores el libro, y entonces no se preocupen por eso, no es normal que tenga errores el libro. Es un libro, todos tienen errores, entonces no pasa nada. Pero por estadística, verifiquen que a todos les haya dado lo mismo que ustedes. Mientras más sean, más pueden ustedes corroborar que en realidad sí fue ese es el problema, ¿no?
Ok.
¿Vale? Bueno, vamos a empezar con la clase de hoy. Um, la clase de hoy va a ser muy ¿cómo se llama? Aplicativa, no sé, práctica. Se llama prácticamente, seguimos en Fundamentals. And fundamentals, we are actually going to go and start doing some exercises related to series pipe flow. When I say series pipe flow, it's just there are pipes in series, so one pipe after another. Okay, so this is the what I want to say. So in this class, we're going to actually put in practice all the knowledge so far that we have learned on continuity, work energy, and Darcy-Weisbach equations. So you already know the equation of continuity, you already know the work energy equation, and you also know the Darcy-Weisbach equation. So, but to be honest, when we're trying to do exercises, so we have to identify the type of exercise that we are doing. When I say so, I want to say that, okay, so hold on, someone is requesting late, of course. So we have to identify several cases of exercises. For example, when I want to identify the type of the problem I want to resolve and I want to do to actually solve it. For example, in pipes or in pipeline networks, we identify in general that we have three categories. The first category is going to be the Q, which is the Q in this case means like we have the pipeline properties. You already know the pipeline properties, the diameter, the length, the roughness, the roughness, E. So you already know many properties of a pipe, sorry, right? And you also can have what? The discharge value. If you have the discharge and the pipeline properties, you will find the losses. In general, the friction losses, or could be, of course, friction losses plus minor losses or local losses. Okay. A second type of problems could be, for example, when you have the same pipeline properties, and then you have the HL, the losses, and then you need to find what? The discharge. These two problems in general are actually problems, analytical problems. In these problems, if in general, in the first one, you don't need to do iterations, you can just go and do it by hand. But in a second situation in this category, so you will have to do some more complex mathematical problems. And in the third category, we call it third category design procedure. Why? Because you're going to design the pipe. In this case, we have the Q, we have the HL, which is the losses and Q, and then you have to find the smallest size D to actually be able to work properly in the system. Okay, with that in mind, we can go to what we can say about the class of problems. So first of all, the type 1 and type 2 problems are analysis problems. So what you need to do is just do analysis. You will have to do analysis. You have to go through all the properties. You have to see if you have the available equations. And of course, as I told you, some of the problems in this type of problems have solution explicitly expressed. So it means that you don't have to do iterations, or you don't have to do any kind of numerical analysis problem. However, for the second category, iterations may be required. Okay. Remember that we have in classes previously, we have something very important, which is if you remember, we have one thing that is very useful, and this is the Moody diagram. If you remember, the Moody diagram is going to give us actually kind of like the first step to do what we are expecting to have as a friction factor. For example, if you have already the Reynolds number, and then you have the relative roughness, so you will have the chance to identify, at least for the problems, in which zone your flow is, right? So you have to identify the flow zone, and then once you know the flow zone, so you can start the iteration, or you can solve the equation that you already know. So give me a second, guys. I have to actually deliver keys because they cannot enter my house. This is closed. Give me a second.